Hi, in this video I'm going to do some more examples from section 2.1, which is about using the first derivative of a function to find its relative minimums and maximums, or minima and maxima if you prefer. Okay, here's my first example. I want to find relative extrema, that just means minimums and maximums, and sketch. And this is my function. G of x equals 16 over x squared plus 2. For my first step, I'm always going to find my critical points. We have a theorem that says that if you have a local min or max, it's a critical point. A critical point is one where the derivative is 0 or undefined. Okay, so to do that I need to calculate the derivative. So I'm going to rewrite g of x like this. I'm just rewriting, I'm not taking the derivative. Now I'll take the derivative. This gives me g prime of x is negative 16 x squared plus 2 to the negative 2 times the derivative of the inside, which is 2x. I just used the chain rule. And I'm going to rewrite this in a nicer way. I'm going to multiply the 16 and the 2x and get negative 32x divided by x squared plus 2 squared. Now I want to look for where this is 0 or undefined. A fraction or a quotient like this is 0 exactly when the numerator is 0. So let me write that down. G prime of x equals 0 when negative 32x is equal to 0. If you think about 0 as a fraction, it has to be 0 over something. So negative 32x is 0 exactly when x is 0. So we have a critical point at x equals 0. Now, can it be undefined? Undefined is like asking about the domain of a function. So we have two rules. Can't take even roots of negative numbers. Well, I don't see any roots, so I think we're okay. And the second rule for domains and things like that is that the denominator can't be 0. We do have a denominator, so let's see if it can be 0. Can x squared plus 2 squared equal 0? No, it's something squared, so it's always positive. In fact, the inside has a square too, so even x squared plus 2 is always positive. But certainly if we square it twice, it's going to still be positive. So we only have one critical point. It's at x equals 0. So step 2, I want to find out what's happening on either side of my critical point. I'm calling this step, what is g prime doing? So I'm going to draw a number line, and I'm going to put my critical point on here. Here, I'll mark it with a star. And I want to know the sign of g prime everywhere on the number line. I know it's 0 here. 0 is not a sign, but I'm writing that anyway. So remember, I have g prime of x is negative 32x over x squared plus 2 squared. So let's just pick a test point. I'm going to pick 1 over here, and I'm going to pick negative 1 over here, and I'm going to evaluate them and see what I get. So g prime of 1, you can pick any number you want. I just like to pick the easiest number. So g prime of 1 is negative 32 times 1 over 1 squared plus 2 squared. So that's negative 32 over 9, which is negative. I don't actually care what the number is. I just want to know, whether it's positive or negative. So over here on the right side, I have that it's negative. And if I do negative 1, it's going to be negative 32 times negative 1 over negative 1 squared plus 2 squared. That's going to give me 32 over 9, which is positive. So it's positive over here. Now in class I gave you a chart that tells you what it means when the derivative is positive on one side and negative on the other, or you can reason it out individually. So looking at the one we have, we know that g prime of 0 is 0, and g prime is less than 0 on the left. Oh, greater than 0. Greater than 0 on the left, and less than 0 on the right. So g, the original function, has to look like this at 0. So at 0 it has a flat space, and the derivative is positive on the left, so it's increasing. So the derivative is positive, so the function is increasing. On the right side, the derivative is negative, so the function is decreasing. It gives us a shape like this. This is really step 3. I'll call it, so what is g doing? Step 3 is just interpreting what your result from step 2 tells you. The conclusion of this in words is, so g has one relative maximum at 0 g of 0. We better figure out what g of 0 is in a minute. And no relative minimums, or minima if you prefer to be fancy and use correct plurals. Okay, let's figure out g of 0 so this makes more sense. So g of 0, I have to plug 0 into my original function. That is 16 over 0 squared plus 2. So that's just 8. So now I'm going to come up here and I'm going to erase my g of 0. I'm going to put 8. So this is usually the answer to the question about maximums and minimums. I have one relative maximum at 0, 8, and no relative minimums. So for step 4, I'm going to sketch g. Here I go. Look, if I remember what my function is, it's like this. G of x is 16 over x squared plus 2. Look at this. The numerator is 16, so it's always positive. It's just a number. The denominator is x squared, which is always positive, plus 2. So this whole thing is always positive. It's good to use whatever you notice about a function when you're graphing it. Okay, and at 0, 8, I'll just put that here. I'll call this 8. It has a relative maximum. So I know it's going to go down from here, but it's always positive, so it can't cross the 0. Oh no, what's doing? Okay, it must go out like this. This is just a guess. I don't know the exact shape of the function. But if it did anything different, it would have to have a relative minimum, right? It would have to curl back up somewhere. This is really the only shape it can have. I'm going to confirm this with my calculator. I'm going to go to y equals and type in my function, which is 16 divided by x squared plus 2. And then I'm going to go to graph. It's like a miracle. It looks just like my picture. So that's what calculus is good for. I'll have to do the second example in a second video because it's hard to post videos that are longer than 15 minutes.